Okay. So first question. Refer to this figure and identify the intersection of plane SVX. So SVX is this plane right here. And STU. STU is this top plane right here. So remember that the intersection of a plane is always a line. Okay? And the line that intersects these two planes is this SV, right? S. Come on, pen. It's going to be one of those days, I think. S. SV. So you just write SV with a line over it, SV with the segment over it. Either one was fine. Let's see if by cleaning this, maybe it'll. Okay. Name a segment skew to WY. Remember, skew lines are not parallel and they'll never intersect. Okay? So a skew line, one's going to go in one direction, one's going to go in the other, and they'll never intersect, but they're really not parallel either. Okay? So if I'm looking for WY, what's one line that's skewed to WY? Or segment? VU, WY, VU, SX, ST, what else? VZ maybe? Those four? So any of those four would have worked. You didn't have to name all of them.
Like across like SU.
Across what?
Like across the plane. Like SU. Like you could do SU.
SU,
No, you can't.
No. Okay. Identify each pair of angles as alternate interior, alternate exterior, corresponding or consecutive interior. 2 and 12. What do you think there? Alternate exterior. Everybody see that? 3 and 5. Alternate interior. 7 and 15. Corresponding. Good. On the same side of the transversal, same location on both lines. Okay. Anybody have questions on that? What about consecutive interior? Name a pair of angles that would qualify as consecutive interior.
10, 13, 11, 16, 2, 5, 3, 8.
Yep. 3, 10, 4, 9, 8, 13, 7, 14. Yep. All of those. So they're on the same side, but they're interior. What's special about consecutive interior angles compared to the other types?
They equal 180.
Yeah, they're supplementary. The other types are all equal to each other. Consecutive interior are supplementary. Okay? Okay, given M and N are parallel, and angle 8 is 86, what's angle 13?
94.
Yeah, they're consecutive interior. So they're supplementary. 94. Given M and N are parallel, if angle 4 is 6x minus 5, and angle 10 is 5x plus 8, where's angle 10? And angle 9 is 3y minus 10. Find the values of x and y. So what can I do there? I'm given 4, 10, and 9. What do we know about 4 and 10? They're equal because M and N are parallel. They're equal. So I could just set 6x minus 5 equals 5x plus 8 and solve. Subtract 5x, I get x. Add 5, I get 13. So x is 13. So what does that make angle 10's value if x is 13?
167.
Well, we just plug it back in to 10, right? What's 5 times 13?
165.
Plus 8.
73.
73. Okay, so angle 10 is 73 degrees. What does that make angle 9? Angle 10 is 73. What's angle 9?
No.
Is it 200?
107.
Yeah.
Yeah, because those are supplementary. They make a linear pair, right? So I know angle 9 is 107, so I can set 3y minus 10 equal to 107. And then solve. So 3y equals 117. What's 117 divided by 3? 99. 39, I mean, yeah, 39. So x is 13, y is 39. That was the question, was find x and y. All right. Slope, hopefully we're getting really good at slope, but just to practice, y2 minus y1 is 9. x2 minus x1 is 15. Always simplify. Question on that? Everybody see it?
If we got it right but forgot to simplify?
Yeah. Negative 15 minus 9. 2 plus 2. It's the slope there, right? Then the last one, 9 minus 14 is negative 5. Negative 3 plus 6 is 3. And that's it. Can't simplify that one anymore. Questions on slope? Everyone's good there? Okay. Okay. Determine whether they're parallel, perpendicular, or neither. So again, I've got to find the slope of both lines and then compare them to each other to see if they're the same, the opposite inverse, or neither. Okay, so the slope of CS, 4 plus 12, 5 minus 1. So that slope is 4. And then KP, negative 6 minus 9, and 6 minus 1, neither. Are you with me there? Let me know if I'm going too fast. I just want to make sure I get through it. Okay. I am recording it, so you can always go back on certain parts and watch if you want. 2 minus 6, negative 4. Negative 3 plus 5, so that slope is 2. 4 minus 10, and 1 plus 2. What does that tell us? Parallel. So number 12 is parallel. And then the last one, negative 5 plus 7, and negative 3 plus 6. Then I have 7 minus 3. And 9 minus 3. Parallel again. So we had 1 neither and then 2 parallel. Okay. Printer's ink charges $1.18 per page to copy a report, plus $12 to bind it. So what's the fixed cost there?
$12.
$12. It's going to be $12 no matter how many pages. That's fixed. Does everybody see that? $12 to bind it. So that's a fixed cost. The $1.18 is dependent on the number of pages. So that's your variable term. 12 is your fixed term. Okay? So write an equation that represents the total cost C to bind and print a report. Remember, the fixed cost is always your y-intercept. The variable cost is always the slope, the number in front of the variable. Okay, and then what would be the cost to bind a 50-page report? Well, I'm just going to plug 50 in here. So what's 118 times 50? 1.18 times 50 plus 12. Questions on how to write that expression or that equation? Makes sense? Okay. All right. Write an equation in slope-intercept form that satisfies the given conditions. Well, I'm given the slope and the y-intercept. This is going to be the easiest kind of equation, right? Because this would be y equals negative 9x plus 3. I just plug it in for m and plug it in for b. b is your y-intercept. So if they give you the slope and the y-intercept, you just write the equation straight from what they give you. Okay? Now this one contains a point. So I know it's going to be 3x plus some y-intercept, and this point is not the y-intercept, so it's not going to help me. So what do I do when they give me a point? Yeah, just plug the point in for x and y. Okay, so 5 equals 3 times negative 1, and now I can solve for b. So 5 equals negative 3 plus b. b is equal to 8. Now I can write the equation, and I'm done. So if you're given the slope and a point, just use the point to plug in for x and y, solve for your y-intercept, and then put the y-intercept into your equation. Questions on that process? Okay, and now here, they give us the x-intercept and the y-intercept. So what are those 2 points, coordinate points? What's the x-intercept?
3, 0.
3, 0, good. Okay, so this is going to be my b, right? I don't need to solve for it. They give it to me. Negative 1 is my b, but I need the slope. So I can use these 2 points to find my slope. Negative 1 minus 0, 0 minus 3. So my slope is 1/3, and my y-intercept is negative 1, because they give that to me. Questions on that? Okay. A group of students start a music club at their school. At the club's first meeting, 5 members sign up. 12 days later, the club has a total of 23 members. If membership increases at the same rate, this is a good clue here. If they ever say membership increases at the same rate, that means it's a line. It's a constant slope, because rate is your slope. Okay, so if it increases at the same rate, how many members are in the club 30 days after its first meeting? So what could I use for the rate, or how do I figure out the rate? What's that? 5 would be your y-intercept. Okay, so the first meeting they have 5 members. 12 days later, 23. So if I subtract 5 from 23, that's 18 members that they got after the first day, right? 12 days later. So 18 members in 12 days. That's the rate that they gained per day. Everybody follow that? Because it's a constant rate. So we gain the exact same members every day, same number. Okay, so this becomes what? The slope is 3/2. So if I wanted to know after 30 days, well, my variable is the days. I could call it x or d, whatever variable you want. But this is the rate I do per day. This is the number of days I do it to find out the total. And then 5 is going to be what was fixed. I start with 5, and then I take 3/2 times the number of days, and I get the number of members. You could call it m. Okay, so the number of days is 30 after its first meeting. So I take 3/2 times 30 plus 5. 30 divided by 2, 15 times 3, 45 plus 5. 50 members. So anytime they say constant rate, that means it's the equation of a line. It means your slope is constant, same slope. So now you had to just figure out what the slope was and what the slope represents. The slope represented the number of members per day. So I knew there were 23 total after 12 days, but they told us there were 5 after the first. So from that first meeting for 12 days, there were only 18 members who were gained. So I did 18 over 12, simplified that to get the slope, wrote the equation, and then just plugged in what they asked me for with 30 days. Questions on that process? Practice on word problems. Okay. Given the following information, determine which lines, if any, are parallel, and then state the postulate. Well, remember, if we're going to use alternate interior, alternate exterior, all of those, when I'm proving two lines are parallel, it's actually going to be the converse of all of those to prove they're parallel. If they're parallel, and I want to prove the angles are equal, I use the alternate exterior angles theorem. But if I don't know if they're parallel, but I know the angles are equal, then I use the converse of the alternate interior angles theorem or alternate exterior angles theorem. So let's look at 1 and 2. What two lines could be parallel if angle 1 equals angle 2? AB and DE, because this is your transversal. So it's going through those two parallel lines, right? So I would write AB is parallel to DE, and the reason is what? What theorem? If A and B are parallel and the transversal is the line, what theorem would say that 1 and 2 are equal? Alternate interior. Yep. So technically, it would be the converse. Because I'm going the other way. I haven't been told they're parallel. So I'm proving that they are parallel using alternate interior angles theorem. All right, how about DAB? Let's look. DAB, so this angle here, and EBC. EBC. If those two are equal or congruent, what is the transversal and what are the two parallel lines? AC is the transversal, okay? AD and BE. Does everybody see that? To, what do we say, BE? And it would be, what reason? Corresponding. So the converse of the corresponding angles theorem. Angles theorem. Okay, if I'm told that ADE, this angle, and BED, this angle, equal 180, what two lines are parallel?
No,
AD and BE. Does everybody see that? The transversal would be DE or DF, however you want to call it. Okay, so this would be the converse of what? What's it called? Those two angles. There's two names you can use. Same side interior or consecutive interior. Either one. Okay. Find the value of x so that A and B are parallel. Find the value of x so that A and B are parallel. Well, what are those two angles if they're parallel? What kind of angles are they? Exterior, because they're outside of the two parallel lines on alternate sides of the transversal. So those are alternate exterior. And what do we know about alternate exterior with parallel lines? They're equal, they're congruent. Okay, so what can I do here to find x? Yeah, not to 180. Yeah, they're equal to each other. They're not equal to 180. And then solve. X is 18. Now, if it asks me to find the angle, don't forget to plug it back in and find the angle. Don't just say I'll solve for x. But this question did ask me for x. Okay? Questions on that one? All right, distance between parallel lines, our favorite. me go back up because I'll just graph these. First step here, graph them. And now use the slope of 1. And then 8. And I use the slope of 1. Something like that. Okay, what's my next point, my next process here, or step in the process? Find the perpendicular line. And what's a good starting point? What would you pick on purpose? The y-intercept. So I could either pick -6 or +8. So I'm going to start here. Using the easy method, where I don't have to set the two equations equal to each other, always start with that one, because if it works, then you're home free. Using the easy method, what slope would I use from this point to find the equation or the line that's perpendicular to these two parallel lines? -1, the opposite reciprocal of 1. So what I'm going to do is I'm going to go down 1 over 1, 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 down 1 over 1. It happens to land on an actual integer point. Yes, just made my day. So the point of intersection is 1, 2, 3, 4, 5, 6, 7, 1. And this point, 0, 8. Do I need any more to find the distance? Nope, I just need those 2 points. So I'm going to draw my triangle. The hypotenuse is the distance I'm looking for. So this distance is 7. This distance is 7. So it would be the square root of 49 plus 49, or 98, right? Because I know that 7 squared plus 7 squared is equal to the distance squared. So the distance is the square root of, so the answer is the square root of 98. I'd prefer you just leave it like that. You don't have to calculate it and write it to the 10th or anything. Just leave it. That's fine. Questions on that? That one turned out to be a nice problem because we didn't have to do any setting equations equal to each other. Let's do the next one. -2x plus 10. Let's see if I can get 10 out of this. 2, 3, 4, 5, 6, 7, 8, 9, 10. -2x. Down 2 over 1, down 2 over 1, down 2 over 1, and so on. And -2x minus 5. 1, 2, 3, 4, 5. And I'm going to go up 2 over 1. Nope. Up 2 over 1. Okay. Somewhat parallel lines. Again, start at the y-intercept. Doesn't matter which. What's going to be the slope of the perpendicular line to these two lines? Opposite reciprocal, which is positive 1/2. So I'm going to pick this y-intercept. I'm going to go up 1 over 2. Up 1 over 2. Up 1. My day is made again. Okay, so now this point is 1, 2, 3, 4, 5, 6, -2. This point is 0, -5. Okay, to find the distance, that's my hypotenuse. There's my right triangle. The units from here to here are 6. From here to here, what's that distance? 3. So now it's just the square root of 36 plus 9. Now remember, if I wasn't so lucky and it didn't end up on an actual intersection of a coordinate point. What do I do now?
You would take the two.
I find the equation for the two lines that intersect. So this one would be the negative 2x plus 10. This one would be y equals 1/2 x minus 5. That's why I intentionally picked the y-intercept to start with. 1/2 x minus 5. Then I set those two equal to each other and solve for x and y. Then once I have that point, I use the distance formula or the triangle method. Okay, there's just one more step in there if it doesn't end up intersecting at an exact integer coordinate point. You've got to find the equation of these two lines, set them equal to each other, and solve for x and y. Okay? All right. Let's see if I can get the board to work. Construct a line perpendicular to L through negative 2, 5. So there's the origin, negative 2, 1, 2, 3, 4, 5. So now they're giving us the point to start with. I don't get to pick the y-intercept. So what do I need first to figure out how to find the perpendicular line? The slope of the original line. Okay? So I'm going to pick 2 points on this line that go through an actual intersection. That point looks like it's 1, 1. This point looks like it's 0, negative 1. Everybody see that? 1, 1, 0, negative 1. Okay? Find the slope. So 1 minus negative 1 is 2. 1 minus 0 is 1. So the slope of this line is 2. Slope of this line is 2. It goes up 2 over 1, up 2 over 1.
Well, we have to show you because like that.
You would have just gone up 2 over 1 on that. Yeah, that's fine. Okay, so now I know the slope of the line perpendicular is going to be what? Negative 1/2, the opposite inverse. So what I'm going to do is I'm going to start at the point they gave me. I'm going to go down 1 over 2, down 1 over 2, and look, it intersects right here. I'm constructing a perpendicular line, sort of. My original point is negative 2, 5. My new point is 1, 2, 1, 2, 3. So to find the distance between them, I just draw my right triangle. Okay? And so this is 2 units. How many units is that?
4.
4, okay. With the right triangle, then, what am I going to do to find the distance? Pythagorean theorem? So it would be square root of?
4 plus 16.
Okay, which is square root of 20. We haven't talked about how to simplify radicals in geometry, so you don't have to do it anymore.
2
This is just the square root of 20.
It would be 2, 5.
2 square roots of 5.
Water.
Yep. Question on that one?
No, you didn't.
So we did the exact same process we've been doing with the others, except this time they didn't give us the point as the y-intercept. They gave us a different point. But it turned out very nicely because we were able to go down 1 over 2 all the way over, right? Okay, bonus. Draw and label a figure you could use to prove the theorem if 2 lines in a plane are cut by a transversal so that a pair of consecutive interior angles is supplementary, then the lines are parallel. What do you think there? If 2 planes are cut by a transversal, 2 lines, so let's do this. There's my 2 lines. There's my transversal. What is it asking? So that a pair of consecutive interior angles is supplementary. So what would I mark as supplementary?
The 2 inside.
On the same side?
Interior.
Like this?
Yeah.
Mark those congruent, right? That little mark means congruent. right? Are not congruent. Good. Good.
Oh, I said that so violently.
So what could I do to this drawing? What could I do to this drawing to make them supplementary? How could I signify that? Anything just with a drawing, or do I need to maybe label some letters?
Use the label letters.
Okay.
Angle.
Okay, so let's do this. And let's go DEF. Okay. So what would I say? Angle
We'll see BC
plus
angle FBB is equal to 180.
Okay, now I've got a figure that would show those two are parallel. That's what you had to do for the bonus.
Could
Okay.
you say, like,
Maybe not like this one, but
could you say
Make it the exact.
line
Yeah.
AE is 180, and then they could like figure that out because they are like congruent-ish?
well, no, because AE, you don't know anything about. I mean, if AE is a line, you still don't know. What if I did two angles like this? I'm just trying to think here. All of these angles added together, right? These two added together are 180. These two added together are 180. They're a linear pair. But you don't know anything about the relationship of those pairs without actually writing that the two inside angles are 180. Then you know the two lines are parallel. Any other questions? The test tomorrow will not be quite this difficult. I always make the review a little harder to get you ready. The test will be multiple choice. However, the problems like the parallel line problems, proving lines parallel, or not parallel, finding the equation of lines or the distance, if you get the answer right and there's no work, I will not give you credit for the problem. You're not going to get credit for guessing. Not going to get credit for guessing, which actually helps you, because if you do the work but you answer it wrong and I can see the work, I can give you partial credit or even full credit if you're like Sam and happen to pick the answer that's not the same as the answer you got. You remember that in last quiz? Yeah. So if your work matches up with one of the correct answers, you'll get credit. But if you choose an answer by guessing with no work supporting it, you won't get credit even if the answer is correct. Okay? I want to give you some choice on your answers, but I don't want to just have you go through and guess on everything. All right. Anyone, do we need to do another problem where maybe the two lines don't intersect at a coordinate? Or is everybody, why don't we try that? I'm going to give you a problem, see if you can do this. Possibly. Plus okay, find the distance between these two lines. First, do they look parallel to you from looking at the equations? Yes. That's the equation of the two lines. Find the distance between them. Huh? It's a good sign. Uh-huh, it was.
What was the other period he was at? First.
He's trying to get into classes
Wait,
more
you
often,
were
which is
first period
good.
today?
Yeah. It's not fun,
It's a good thing.
Well, first off, you gotta draw your lines. Oh. So -6 and +2, those are gonna be your two y-intercepts for the two different lines.
Yep, first step, draw the lines. Second step, pick a point, preferably the y-intercept of one of the two
Yeah.
lines,
Oh, up 3 over 1.
and use the slope for the perpendicular line.
Reciprocal of 3x is -1/3.
Right.
Doesn't that still land on foot?
Let me look at Sam's.
No.
I don't think so. It does, but it doesn't end on an integer point. You know what I mean? I mean, your point ends there, but when you connect them, where it intersects between the two lines does not end up on a integer point. So now, what do you do to find what that coordinate is? Yeah, find the equation of both lines and set them equal to each other. Find the equation of both lines that intersect and set them equal
So once you find x, you just plug it back in.
to either one of the equations that you
The
start with.
original ones?
Uh-huh.
So we would set -1/3 x.
Plus whatever your y-intercept is.
Equal to one of the other equations.
Yeah. And just so we don't run out of time before I do this one, and I'll just start doing it up here for you.
You take one of your y-intercepts on the two, and then you take the opposite numbers.
1, 2, 3.
So it's -1.
Well, do you know what's
So I'm looking for the intersection here, because I know the coordinate here, but I need to have this point. So this equation of this line is y equals -1/3 x plus 2. This line. The equation of this line is the one that has the y-intercept at -6. So now I'm going to set these two equal to each other. An easy way to get rid of the fraction?
Multiply everything by 3. Or the denominator.
Does it have to be the opposite line? Because I tried to.
Yeah, because you already know this point.
Okay.
Yeah. -x plus 6 equals 9x minus 18. So 8x equals 24. 24 over 8 is 6 over 2, which is 3. That doesn't make sense.
I got?
Well, mine
You got
makes
3? Okay.
sense.
Oh, I got 6/5.
I got 0 over 8.
Negative, so 18 and 6 is 24,
Serious.
plus 1, that's 10. Sorry. Bad math. Okay. So it's 24 over 10, which is 12 over 5.
I didn't even
Right.
said that until like 20 minutes ago.
Okay. So this point is 12/5. Now what do I do with that number?
You plug it back into one.
I'll just do it in this one. 3 times 12/5 plus 2 is 36/5 plus 10/5, right? If I get a common denominator here, which is 46/5.
So you said you made the test easier to review, right?
Yeah.
Going by that logic, each other review both had like it
They
landed
ended up,
on one-
we'll see.
Okay.
Okay, so what do I do with this point? I heard Sam say that. Well, we have this point and we have this point now. So I just draw this triangle, right? The distance from 2 over to 12 fifths is just 12 fifths. So this is 12 fifths. Well, 2, I know. 2 to 46 fifths, that doesn't make any sense.
I had like 30.
Because look at this point. This point's definitely just a little over 1, right? If I put 12 fifths in here, I get 36 fifths plus 10 fifths. It's 46 fifths.
Wait, are you sure it's not 6 over 5?
That's what I got.
You got 6 over 5?
Yeah,
This
because
one-
I put it into the other equation.
This one says 46.
So you did the
24.
Drive it.
I put it in this equation, the minus 6 one, right?
Yeah.
And then 1/3 x.
plus.
You put it in the plus 2.
That's what I did.
Well, I can put this number into either one, but
Truck says trendsetter.
it doesn't, it shouldn't matter. Oh, it should matter.
Yeah.
It should matter, yeah. So what'd you get?
Same point.
6 fifths?
6 fifths.
That's better. Okay. So this is 10 fifths minus 6 fifths, so that's 4 fifths, that distance.
How do you know which equation to put it in?
Well, I've got to put it back into either this one or this one. So I could put it back into this one or this one, because those were the two I used. Thank you, that's 6 fifths. And now I just take this squared, which is 16 25ths, plus this squared, which is 144 25ths, and put that in the calculator. And you have the distance. Okay?
Thank you.
You're welcome.